Some examples on current division. Let's say we have a circuit given like this. We have a resistor right here and also another resistor right here. And then the current going through this one is 5 ampere. And let's say the resistance right here is 4 ohm resistance. And the resistance right here is 8 ohm resistance. What's going to be the current in the current through the R1 resistance and the R2 resistance? There are multiple ways you can solve this problem. One of the ways you can logically think like when you have higher resistance, the current going through is going to be lower. And also if you look at the resistance, here we have 4 ohm resistance and then here we have 8 ohm resistance. So whatever the current going through this is going to be half of that current. It's because when we have, if you look at the Ohm's law, that is V is equal to I times R, when the relationship between current and the resistance is inversely proportional, because if you rearrange this one, you're going to have I is equal to V divided by R. So whenever the resistance increases, the current value is going to decrease. So you can, from that we can see that the higher the resistance, the lower the current is going to be. And from the resistance given, we know the current going through this 4 ohm resistor is going to be double the amount of current going through the 8 ohm resistance. So we have to have a value that add up to, let's put this as 6. Okay, let's put this on as 6. So add up to 6, and also here we have to have a half of this one, and here we have to have a double of this one. So for that one to happen, we can make this one as 2 ampere and this one as 4 ampere. Okay, so from this one we can get 6 ampere. This is one way to do it. The another way you can do it is you can find the voltage. Okay, voltage. Can I find the voltage? Yeah, I have the resistance, but I don't have the current point. So voltage is, you can find the voltage once you find the current, but you cannot directly find the current. So we can use the current division formula. Current division formula says that current, whatever the current you are trying to find, for example, let's say call this one I1 and let's call this one I2. Whatever the current you are trying to find is going to be equivalent to current source multiplied by the other resistance. Like if you are trying to calculate the current passing through the R1 resistance, then you have to put the other resistance on top and then divided by the total resistance, that is R1 plus R2. So here we are going to have the current source, that's we know that 6 ampere, and then R2 resistance, that is 8 ohm resistance, and then we have the total resistance, that is 12. So this is going to be 2 right here. 8 divided by 2, we get 4 ampere. That's what we did without calculating. Now if you want to calculate I2, you use the same formula. I2, the current source, multiplied by the other resistance, that is R1 divided by R1 plus R2, and we know the current source, that is 6 ampere, and then R1 is 4 ampere divided by the total resistance, and R1 is 4 ohm resistance, and the total resistance, that is 4 plus 8, that is 12, and then we are going to have 4 divided by 2 ampere. And you know, instead of doing this, you can also directly find this one using KCL. Like KCL is whatever the current going in is equal to going out. So if the 4 ampere is going through this, then you know the rest of them has to go through this. So you can directly find using KCL as well. Okay, so from that, if you want to find out the voltage, now you have the current, you can find the voltage using V is equal to I times R. So if you want to find the voltage across this resistance, I can use the V, let's call this one V1. V1 is equal to I1 times R1, and I1 is 4 ampere, and the resistance across this one is 4 ohm resistance. So 4 ampere times 4 ohm resistance, we are going to have 16 voltage. And if you want to find out the voltage across this R2 resistance, you can use the Ohm's law as well. V2 is equal to I2 times R2, and here the current we found out, that is 2 ampere, and then the resistance across this voltage is 8 ohm resistance. So 2 times 8, that's 16 voltage. Okay, that makes sense because when we have voltages in parallel, it's going to be same everywhere, so it's going to be equal voltage. So this makes sense. Now let's look at another problem. I'm going to go ahead and erase this one. So we have seen we can apply the current source when we have two resistors in series. What if we have 3 resistors in series? Three resistors in series. Okay, let's say we have R1 resistance that is equal to 2 ohm resistance, R2 is equal to 4 ohm resistance, and then R3 is equal to 8 ohm resistance. Let's say we have the current passing through this 14 ampere, and we want to find out what are the current entering through R1, R2, and R3. Okay, this is 4 ohm resistor. Now to find this one out, if you look at my last example, I used the current division. Like we did this formula, right? I is equal to I, whatever the current we are trying to find. Let's say this, let's call this one I1, let's call this one I2, let's call this one I3. And to find out the current, what we did is we put this formula I1 is equal to I source times the other resistance on top. So we had a resistance on top and then addition of all the resistance, but that will work if we have 2 resistance in parallel. But when we have 3 resistance, we cannot use it. We had to use other form. One thing you can do is you can combine 2 resistors and solve it. Like you can find the equivalent resistance of these two, and then you can apply this current division formula. But if you have 3, if you want to directly find it, you can use this one as well. Like if you have 3 and you want to directly find it, you can use this formula. I1 is equal to I total current, and then that one multiplied by whatever the current we are interested in. So for this one, if we have R1, that's like if you want to find the current going through the R1, that's the resistance we had to put right here. So I over 1 over R1, and then adding all the other resistance, like adding all the resistance. 1 over R1 plus 1 over R2 plus 1 over R3. Now let's plug all the values. We know the total current, that's 14 ampere, and then 1 over R1, that is 1 over 2, and then 1 over 2 plus 1 over 4 plus 1 over 8. Okay, and if you simplify this one and solve for this, you're gonna get 8 ampere for the I1. Now let's look at the I2. I2 exactly the same step you have to follow. Let me put this in a different color. I2 is going to be equal to total current, and then for this one you have to put 1 over R2, and then addition of all the resistance. 1 over R1 plus 1 over R2 plus 1 over R3. Now let's plug all the values. 14 ohm current, 14 ampere current, and then 1 over 4 here, 1 over 4, and then 1 over 2 plus 1 over 4 plus 1 over 8. And if you calculate this one, you are going to get 4 ampere. And for the third one, you don't have to do all these things. You can simply apply KCL. KCL says whatever the current goes in is equal to current goes out. So here we have 8 ampere going through this already, and then we know the 4 amperes going through this. So totally we have 12 amperes gone. The rest of the 2 ampere has to go through this. So I3 is equal to 2 ampere. You can actually apply this formula and you're gonna still get the same answer. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.